Hi there, this is going to be episode 4 in our little mini series solving trigonometric equations. So to start out this video, I want us to go back to something that we learned in algebra. And in algebra, we learned how to solve this for 0. Now, if you're trying to solve this, if you're trying to figure out what values of x are going to make this true, your first instinct might be to add 1 and do some craziness. I will tell you that if you try to add 1 and do some craziness, you're not going to get anywhere. You're going to get stuck, you're going to get frustrated, you're going to get annoyed, and you're going to want to give up. If you see more than one term that has an x in it, you want to get everything on the same side of the equation, and you want to set it equal to 0. Then you have a whole different plethora of ways to factor. If all you had was 2x squared minus x, you take the greatest common factor out. Because we have that minus 1, we have to figure out what times what. When I multiply all of this out, when I multiply boom, 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 do I get this? Now remember, this first set right here, this times this, is always going to equal that. Those two together are always going to be your squared term. It's always going to be that squared term because of the way that it's laid out. And then this one and this one are always going to be your constant term, just for the way that it's laid out. But how does that middle one come into play? Well, the middle one comes into play. I'm trying to find another color. From this one being multiplied together, added to this one being multiplied together. A lot of that comes from just having good number sense. And so you have to be able to kind of see how these numbers work out and how they multiply and add together. So when I am looking at this right here, if I'm trying to figure out what goes in my pink boxes, the only way to fill in those pink boxes is going to be a 2x and an x, because 2x times x is 2x squared. If I'm trying to fill in my purple circles, the only way to fill in the purple circle is going to be 1 and 1, because 1 times 1 is 1. But now I need to figure out that middle term. So I need the middle term to add up to -1. Where does that middle term come from? That middle term comes from multiplying these two and these two together. So let's look at this for a second. I'm going to erase my little lines. I don't know if this whiteout's going to work. It's all, well, it's broken. You see that? Okay, so we're going to erase these lines for a second. And I want us to multiply this out without any signs. Okay, so there's no signs right now, and we're going to multiply this out. 2x times x is 2x squared. 2x times 1 is 2x. Then we jump down to our next set. 1x times x is x. 1 times 1 is 1. Now, I left all of my signs out because we haven't put our pluses or minuses there. And I want us to look right here. Right here, I need this to be a -x when I add up my like terms. Now, these are like terms. To make that add up to a -x, this has to be negative and this has to be positive. -2x plus x is going to be that negative. So that being said, when I multiplied my 2x and my 1 over here, that needs to be negative. This needs to be positive, which means a positive times a negative is going to be a negative there. So these are all equivalent. This is the factored form. This is an expanded form. That's standard form. All of them have different names. So my final factor form for this is 2x plus 1 times x minus 1. Now, if we need to find our zeros for this, we're going to set each factor equal to 0, and we're going to work it all the way through. So I'm going to subtract a 1. I'm going to divide by a 2. There's one of my zeros is that x equals -1/2. If I plugged in a -1/2 into there, I would get 0. That's what a 0 means. So let's take our handy dandy Desmos. Let's erase all the crap we have in there. Let's put f of x equals 2x squared minus x minus 1. And let's say plug in f of negative a half. And your output is 0. That's what we're looking for, is what values of x can we plug in where our output is going to be 0. Now we do the same thing with this. We set this equal to 0. We get x minus 1 equals 0, x equals 1. If I plug a 1 into here, I get an output of 0. It's also where it crosses the x-axis, is at 1 and negative a half. So that was back algebra 1 that we learned that. That was factoring. You have to have good number sense to be able to work your way through it. But this is factored form. This is standard form. These are our zeros. How do we apply that to solving trigonometric functions? Well, let's say we have this. 2 sine squared of x minus sine of x minus 1 equals 0. We are going to do the same exact thing where our factored form, we need to figure out what times what is going to give me this. This is really similar to the one before, where our first two terms every single time have to multiply to be that. So my pink boxes have to multiply to be that pink box. And my purple circles have to multiply to be that. So what that means is my pink boxes have to multiply to be 2 sine squared. This has to be 2 sine of x and sine of x. 2 sine of x times sine of x gives me that 2 sine squared of x. My purple circles have to multiply to be 1, and specifically negative 1. So it has to be 1 and 1, but one of these has to be negative. How do I figure out which one's going to be negative? Well, I can swoop right here, and that's going to be a positive sine of x. I can swoop right here, and that's going to be a positive 2 sine of x. But if I add those together, I get 3 sine of x, which is not what I want. I want a negative 1 sine of x. So if I make this one be negative and this one be positive, then it's going to add up to that negative sine of x like we want in that middle term. Of course, you can multiply this all out if you need to, but it's the same exact process that we did up here. So it's that same exact process. This is the factored form, and we're setting it equal to 0. When we set it equal to 0, we take each of our factors. So we're going to take 2 sine of x plus 1. We're going to set it equal to 0, and we're going to solve all the way through. I'm going to subtract 1. I'm going to divide by 2. And then I'm going to inverse sine both sides. When I inverse sine, I take my handy dandy cheat sheet chart. It's a sine, so I'm going to go down the sine column, and I'm going to find anywhere I can find a negative 1/2. So I can find a negative 1/2 right here at 7 pi over 6. And I find a negative 1/2 at 11 pi over 6. But I'm not done yet. I've only worked with 1/2 of it. And so I'm going to have more answers. So I'm going to take this side and I'm going to set it equal to 0. I'm going to solve it all the way through. So I'm going to add a 1. I'm going to inverse sine this. And when I inverse sine it, I'm going down that sine column and I'm looking, when does sine equal 1? It equals 1 at pi over 2, and that's it. So here, my x is pi over 2. My final answer for this is putting all of those together. So my final answer is x equals pi over 2, 7 pi over 6, and 11 pi over 6. That's my final answer. If you want to check your work, if you want to know if you're correct, you're going to take Desmos and you're going to type in your function. So your original function was sine squared of x minus, was it 2? 2 sine squared of x minus sine of x minus 1, and you're going to set it equal to 0. And we only care from 0 to 2 pi. So we only care about from here to here, and our answers are pi over 2, 7 pi over 6, and 11 pi over 6. So we know we did that correctly. So when you see a function that has more than one term with an x in it, you want to move everything to the same side of the equation, set it equal to 0, and then find a way to factor. Sometimes you're going to factor with the greatest common factor. Sometimes you're going to factor with guess and check.